Cambridge iGCSE Chemistry, moles and the calculation of limiting reactant. We will start with a review of mole ratio, reacting mole ratio, then review a mass change calculation before moving on to limiting reactant ideas. So let's just review reacting mole ratio. The reacting ratio in moles in a chemical reaction is fixed. That is, in a balanced chemical reaction equation, the 2 Mg plus 1 O2 goes to form 2 MgO, 2 magnesiums and 1 oxygen go to form 2 magnesium oxides. Can be thought of as stating that 2 moles of magnesium reacts completely to form 2 moles of magnesium oxide. This is a fixed ratio. 2 moles of magnesium will form 2 moles of magnesium oxide. 1 mole of magnesium would form 1 mole of magnesium oxide. Half a mole of magnesium would form half a mole of magnesium oxide, and so on. So if I show the incomplete statement for oxygen, what's the mole ratio between oxygen and magnesium oxide? Pause, speak it out or write it down, come back to check. Okay, so looking at the equation, 1 mole of oxygen will react to form 2 moles of magnesium oxide. So it's a fixed ratio. However many moles of oxygen we start with, we'll get twice that numbers of moles of magnesium oxide. So let's carry out a mass change calculation. We've got a balanced chemical equation. 2 moles of calcium, 1 mole of oxygen to 2 of calcium oxide. So we have a fixed mole ratio of 2 to 1 to 2. From that, we can predict the mass of calcium oxide formed from a starting mass of calcium. The first step is to change the mass of calcium into a numbers of moles. We achieve that, just to review, as 4 divided by 40, where 40 is the molar mass of calcium, that is the mass of 1 mole. That, of course, forms 0.1 moles of calcium oxide because we have a 2 to 2 reacting ratio, so a 1 to 1, a 0.1 to 0.1. So we form 0.1 moles of calcium oxide, and now we need to turn that into a mass. So the mass will simply be the numbers of moles times the molar mass, the mass of 1 mole, which is 0.1, that's the numbers of moles, times 56. Calcium is 40, oxygen is 16. Comes to 5.6 grams. So 3-step process: turn the mass into numbers of moles, transfer the numbers of moles using the reacting mole ratio in the equation, and then convert the numbers of moles back into a mass by multiplying by the molar mass, or the mass of 1 mole. Problem number 2, what is the mass of calcium oxide formed starting with 0.16 grams of oxygen? Pause, complete the calculation, then come back to check and correct. Okay, so to reveal, we convert 0.16 grams into 0.005 moles of oxygen by dividing by 32. Each oxygen is 16, there's 2 oxygens, 32. Now we use the reacting mole ratio to predict that that would form, on complete reaction, 0.01 moles of calcium oxide. 1 mole of oxygen makes twice the moles of calcium oxide. 0.005 moles of oxygen makes twice that number of moles of calcium oxide. Then we multiply the moles of calcium oxide by the molar mass, the mass of 1 mole of calcium oxide, which we get from 40 and 16. makes 56. So 0.01 times 56, 0.56 grams. Now on to the point of the lesson, limiting reactant. In reactions involving more than one reactant, let's take sulfur and magnesium forming magnesium sulfide. One sulfur, one magnesium to one magnesium sulfide, a 1:1:1 reacting ratio. I can represent that pictorially with sulfur atoms, magnesium atoms, and then sulfur and magnesium ions. In any test tube reaction, we may have started with exactly reacting numbers of reactant particles. But what if the numbers of particles did not exactly match the reaction ratio? Let's imagine that we start with 4 magnesium atoms and 7 sulfur atoms. The reaction will stop when the particles of one of the reactants are consumed. How many units of magnesium sulfide could be made starting with 4 magnesiums and 7 sulfurs? Pause, think it through, come back to check when you are ready. Okay, so if we've only got 4 magnesiums, we can only have 4 units of magnesium sulfide. That is, 4 magnesiums will combine with 4 sulfurs. Well, that leaves 3 sulfurs uncombined. The amount of magnesium sulfide formed is limited by the number of magnesium particles, so we call magnesium the limiting reactant. We would refer to sulfur as being in excess, in that some unreacted sulfur remains at the end. This problem has 1.2 grams of magnesium and 1.82 grams of sulfur reacted to form some magnesium sulfide. The question is, identify the limiting reactant and calculate the mass of magnesium sulfide formed. Well, we have an equation, 1 magnesium to 1 sulfur to 1 magnesium sulfide. The first step is to calculate the moles of magnesium. Well, 1.2 grams divided by 24 is 0.05 moles. But how many moles of magnesium sulfide could be formed from 0.05 moles? Well, it's a 1:1 ratio, so that would be 0.05 moles of magnesium sulfide. Now we need to repeat that process for sulfur. 1.82 grams divided by 32 gives us 0.057 moles. That could form 0.057 moles of magnesium sulfide. We then look at the 2 potential numbers of moles of product and identify the smaller number of moles. This, of course, comes from the limiting reagent. So the magnesium is the limiting reactant in that it could only form 0.05 moles, whereas the sulfur, if fully reacted, could form 0.057, a greater number of moles. So take the smaller numbers of moles as indicating the limiting reactant. So we then work out the mass of magnesium sulfide formed. Of course, we need to use the smaller number of moles. So numbers of moles times the molar mass of magnesium sulfide. Just to be clear, 24 for magnesium, 32 for sulfur comes to 56. So numbers of moles times the molar mass comes to 2.8 grams. So I'm going to set out the calculation method. Step 1, calculate the number of moles of each reactant. For each reactant, use that numbers of moles to predict the maximum moles of product formed, taking into account the reacting mole ratios. The smaller amount in moles of product gives the limiting reactant, and the moles of product formed. Using the smaller number of moles, calculate the mass of product formed. So I'd like you to attempt this problem. A mixture containing 2.3 grams of sodium is mixed with 3.2 grams of sulfur to form sodium sulfide, Na2S. Identify the limiting reactant and calculate the mass of sodium sulfide formed. Here's the balanced equation. Note there is a 2:1:1 ratio. 2 moles of sodium form 1 mole of sodium sulfide. 1 mole of sulfur forms 1 mole of sodium sulfide. That will be relevant in your calculation. Come up with the mass of sodium sulfide formed and through identifying the limiting reactant. Pause the lesson, complete the calculation, come back to check and correct when you are ready. Okay, so let's reveal the first few steps. I need to convert the mass of sodium into numbers of moles, 0.1, and then predict the moles of sodium sulfide that could be formed on complete reaction, 0.05 moles of sodium sulfide. I then repeat that process for sulfur, again 0.1 moles. So it would appear that we've got the same numbers of moles of the two reactants, but the key thing is how many moles of product could be formed. 0.1 moles of sodium could only form 0.05 moles of sodium sulfide, 2:1. However, 0.1 moles of sulfur could form 0.1 moles of sodium sulfide. It's a 1:1 reacting ratio. So which is the smaller numbers of moles? The sodium sulfide coming from the sodium. So sodium is the limiting reactant. So it's the moles of product formed from the sodium that we use to calculate the mass of sodium sulfide formed. So numbers of moles of sodium sulfide times 78 equals 3.9 grams. Repeat the lesson if you think it's necessary. It's up to you. Try some textbook questions. Practice is crucial in this topic. Then go on to past paper questions, but make sure you have access to answers. If you feel you've learned some chemistry from watching this lesson, please like, please subscribe.